Hey everybody, this is the last video in section 2.4, and we're going to wrap things up here with what I've simply called a nice result from one-sided limits. And I wanted to throw this in because it comes up in some other classes you might take. So just so that you know where this property comes from. So this is a theorem from our book. And the proof of this, you are not going to get tested on the proof of this at all. It's pretty long and geometric. It uses the unit circle, and it also uses one-sided limits, as you can see from one-sided limits. It uses the sandwich theorem, so it's got a lot of stuff wrapped up together in this proof. If you're interested in checking it out, it is in your e-text on pages 68 and 69, so you can take a look if you would like. But the theorem, the part we're interested in, is a special limit. The limit as theta approaches 0 of sine theta over theta, that's our function. That limit equals 1. Okay. And this is trig based. Theta is an angle in radians just by default. So theta's default is to be in radians. But notice that we are looking at very, very small angles theta. Theta is getting close to 0. So these are really teeny tiny angles here that we're looking at. And why we are interested in this theorem, or where else you might see this, is in your physics class, if you take physics. This is useful for certain approximations in physics. Okay. The one that I can think of right off the bat is a derivation of a equation for harmonic motion, kind of like a pendulum type deal. And in order to simplify the calculations quite a bit, you have to use this limit, this theorem, this result there. Otherwise, it's a very, very difficult equation to work with. So what this theorem is telling us is that as an angle gets smaller and smaller, so we'll say as an angle gets very small, because that part we're talking about theta approaching 0, really, really small angles. The sine of that angle divided by the angle, so the ratio of those two things approaches 1. So that means, this means that since that fraction is about equal to 1, the numerator and denominator are about equal to each other, because, you know, if you divide something by an approximately equal number, you get a result that's about equal to 1. So this means that the sine of theta is approximately equal to theta. Okay, so the sine of the angle and the value of that angle are almost the same for very, very small angles. And that's the useful thing. So in certain equations, as an approximation, sometimes it will be difficult to use a trig function in there. And so this, if we assume theta is very small, this allows us to replace that trig expression with just theta itself. Okay, so this only gets used in certain cases, It is still just an approximation, but this can be a handy one. So I just wanted to make sure that we were aware of it. And that's the end of section 2.4.